Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You begin by locking goals and scope. Be specific about who will use it and why. Once set, pick an implementation model, interpreter for rapid feedback, compiler for speed, then choose a host language you know well. Next, design a tiny surface syntax and core type set so you can implement a parser fast. Start with a REPL or script runner so you can run examples immediately and iterate. This early loop reveals design flaws long before optimization. Once you have a REPL, build a robust lexer and parser. Prefer recursive descent for control, so you produce a clean ASD. Then lower that ASD to an intermediate representation. This is where you perform analyses and simple optimizations, and it separates front-end from back-end work. Make semantic checks now, resolve symbols, enforce scopes, and implement type rules or inference. These steps prevent downstream complexity when the IR is stable. The rest of the toolchain becomes far easier to build and maintain. To finish, pick a backend. A simple bytecode VM for portability or native CodeGen for speed, and implement core runtime primitives in a tiny standard library. Once CodeGen exists, build tooling, package manager, formatter, test suite, and SCI so contributors can reproduce results. For release, version the language, document breaking changes, and ship samples. If things go wrong, isolate the smallest failing program. Add logging at each compiler stage, and bisect between parser and IR to find the root cause quickly.
Thanks for watching. Subscribe to keep your life in tune.